On the path of becoming a penetration tester, you are learning about SSRFs. In the first part of this video, we looked into what an SSRF is. We've looked into SSRF examples, which have been really useful. We've looked into how to find SSRFs, and this was also an extremely useful example, even though despite the fact that I am a major critic of everything, this has been really well put up by the folks over here at TryHackMe. And we've said that in the second part of this video, which is now, we're going to look into ways to mitigating SSRF attacks, so server-side request forgery attacks, and also hopefully we get to look into the Ssrf Practical, which is an example to test SSRFs in a fictional scenario. So defeating common SSRF defenses. Now, more security-savvy developers aware of the risks of SSRF vulnerabilities may implement checks in their applications to make sure the requested resources meet specific rules. A lot of theory here. There are usually two approaches to this, either a deny list or an allow list, and I would say that the best way to go about it is to use an allow list. A deny list is where all the requests are accepted apart from resources specified in the list, such as a blacklist, for example. A web application may employ a deny list to protect sensitive endpoints, IP addresses, or domains from being accessed by the public, while still allowing access to other locations. Now, a specific endpoint to restrict access is the local host, of course, which may contain server performance data or further sensitive information. So domain names such as localhost and 127.0.0.1 are usually by default on the block list. Attackers can bypass a deny list by using alternative, so these are evasion techniques by using such as 0, 0000, 0000. They all point back to the local host 127.1, 127.****, 21307064333. I believe this is a numerical representation of the local host. Another one, or subdomains that I have a DNS record which resolves to the IP address of localhost, or this one, or even hosts on the internal network. Also, in cloud environment, it would be beneficial to block access to the IP addresses, which is the metadata information, of course, usually in AWS, but I believe this is the default address for GCP metadata as well. An attacker can bypass this by registering a subdomain on their own domain with the DNS record that points to the address, which is really interesting, which is a really interesting approach. Now, an allow list, which I told you about, that I would use if I were working in cybersecurity defense, an allow list is where all requests get denied unless they appear on the list. So this is a whitelist, or match a particular pattern, such as a rule that an URL used in a parameter must begin with. An attacker could quickly circumvent this rule by creating a subdomain on an attacker's domain name, such as this one. The application logic would now allow this input and let an attacker control the internal HTTP request. Now, this is often what happens. Open redirect. If the above bypasses do not work, there is one more trick up the attacker's sleeve, the open redirect. Now, an open redirect is an endpoint on the server where the website visitors get automatically redirected to another website address. Take, for example, the link. This endpoint was created to record the number of times visitors have clicked on this link for advertising marketing purposes. But imagine there was a potential SSRF vulnerability with stringent rules, such as a block list or an allow list, which only allowed URLs beginning with this thing. An attacker could utilize the above feature to redirect the internal HTTP request to a domain of the attacker's choice. Now, leaving aside all this theory and making sure that we're recording here, let's actually answer these questions. What method can be used to bypass strict rules? Open redirect, What IP address may contain sensitive information in a cloud environment such as AWS, GCP, and maybe Azure? 169.254, 169.254. What type of list is used to permit only certain input? An allow list. To stop certain input, a deny list. And now let's go into the Ssrf Practical. We've come across two new endpoints during a content discovery exercise against the Acme support website. The first one is private, which gives us an error message explaining that the content cannot be viewed from our IP address. The second one is a new version of the customer account page, such as customers new account page, with a new feature allowing customers to choose an avatar. Now, I don't think, is it? Yeah, it seems to be working. Interesting. Seems to be working from the browser as well. Begin by clicking the start machine, which I did. First, create a customer account and sign in. So we go to customers. Let's say Christy, password Christy, log in. Sign up here, of course. So Christy at Christy.com. Christy, don't do that. Alright. Never, don't save this one. Once you sign in, go to this one, go to this page to view the new avatar selection feature. By viewing the page source of the avatar form, you'll see the avatar form field contains the path to the image. So let's actually look into Control U to actually view the source and see what they're talking about. So call access. We have call access for, of course, so this is actually the path. Alright. The background image style can confirm this in the above div element as per the screenshot below. If you choose one of the avatars, then click the update avatar button, you'll see the form change and above it display your current selected avatar. If we click on update avatar, this is my current avatar. Viewing the page source will show your current avatar is displayed using the URI data scheme. So Control U, Control F, current avatar. Which is exactly what we've seen. Now let's try to make the request again, but changing the avatar value to private in hopes the server will access the resource and get past the IP address block. To do this, first right click on one of the radio buttons and inspect all. So inspect element, which we're doing in Chrome here. And then click update avatar button. Unfortunately, it looks like the web application has a deny list in place and has blocked access to the private endpoint. So let's see if we have a private value. So I've clicked on the inspect. The private should be here somewhere. Oh, right, so I have to set the value of call access for set to private. All right. And then click update avatar. Let's see if we can update. Weird, so we didn't get the message they said we're getting. So once again, Let's click on inspect element over here. Okay, let's click on the radio button and then click on inspect and then set the value to private and then update. I mean, that's what they did. So URL cannot start with private. As you can see from the error message, the path cannot start with /private. But don't worry, we still got a trick up our sleeves to bypass this rule. We can use a directory traversal trick to reach our desired endpoint. Try setting the avatar value to X. Where was it? Again, inspect element. We need to set it to X. /private. Alright, and then we click on update avatar. And in this situation, avatar updated. Viewing the page source of the avatar form, you'll see the currently set avatar now contains the contents from the private. So if we look at the contents of the avatar somewhere over here, where was it? Call access. This is base 64. This is what we might be looking for, but let's see. Maybe or maybe not. Yes, that's what we were looking for. You'll see the current set avatar now contains the contents from the private. So let me actually get back a few steps and explain. Now, when we did the trick of updating the user avatar to forward to X, in this case /private, it's going to load the contents of this thing because it didn't appear on either the block list or it bypassed the allowed list. And what it did, it actually updated the current avatar with the contents of that specific private location. And in this situation, it says data image /png and the base 64. Usually it's an image if it says data image /png. Usually it's an image, but in this case we got a message in base 64 which we've decoded into the flag. And that's it.